A Brief History of Time was written by Stephen Hawking. He wanted to help people understand big ideas about space, time, and how everything in the universe works. The book was first published in 1988, and it became very popular because it explains difficult science in a way that many people can understand. Even though some ideas are complex, Hawking tried to make them simple and interesting. He also included questions that people often ask, like where the universe came from, and if time has a beginning and an end. The book starts by talking about how people have tried to understand the universe for a long time. In the past, people thought the Earth was the center of everything. They believed that the sun, moon, stars, and planets all moved around the Earth. This idea was called the geocentric model. Later, scientists like Copernicus and Galileo showed that the Earth actually moves around the sun. This was a big change in the way people saw the universe. Then Isaac Newton discovered laws of motion and gravity, which helped explain how planets move in space. He showed that objects in space follow the same laws as objects on Earth. Later, Albert Einstein changed our understanding of space and time with his theory of relativity. Hawking explains these ideas step by step so that readers can follow how our knowledge has grown over time. One of the big ideas in the book is about the nature of time. People usually think of time as something that moves forward in a straight line. We experience time every day when we see the sun rise and set, or when we notice that we are getting older. But Einstein's theory of relativity shows that time can change depending on how fast someone is moving or how strong gravity is in a place. This means time does not always flow the same way for everyone. For example, astronauts who travel at very high speeds might age slower than people on Earth. This is called time dilation. If an astronaut travels in space for what seems like a few years, they might return to Earth and find that many more years have passed here. Hawking also talks about black holes, which are places in space where gravity is so strong that nothing, not even light, can escape. He explains that black holes can shrink over time because of something called Hawking radiation, a discovery he made himself. This was an important idea in modern physics. He describes black holes as being like whirlpools in space, pulling in everything around them. If someone falls into a black hole, they would not be able to get out. However, Hawking's theory suggests that black holes are not completely black. They slowly release energy and might eventually disappear. Hawking also talks about the beginning of the universe. Many scientists believe that the universe started with the Big Bang, a huge explosion that happened about 13.8 billion years ago. Before the Big Bang, there was no space or time. Everything started at that moment. Scientists study the light and radiation left over from this explosion to understand what happened. Hawking explains how small changes in the early universe led to the formation of galaxies, stars, and planets, including Earth. He also talks about the possibility that the universe might not have had a clear beginning and that time could work differently than we think. Some scientists suggest that the universe may have gone through cycles of expansion and contraction, meaning that it might not have started from a single point. There's also the idea of a multiverse, where there could be multiple universes existing at the same time. Another interesting part of the book is about the possibility of time travel. Many people wonder if time travel is possible. According to Einstein's equations, time slows down for objects moving very fast. Some scientists think that if we could find a way to move close to the speed of light, we might be able to travel into the future. Imagine a spaceship moving at nearly the speed of light. The people inside would experience time more slowly than people on Earth. If they traveled for what felt like a few years to them, they might return to Earth and find that hundreds of years had passed here. But traveling to the past is much harder and may not be possible at all. Hawking explains these ideas in a fun way, making readers think about what time really is. He even discusses the idea of wormholes, which are like tunnels in space that could, in theory, connect different points in time and space. However, scientists do not yet know if wormholes actually exist or if they can be used for time travel. Hawking himself believed that time travel to the past is unlikely because it could create logical problems, such as the famous grandfather paradox, where someone could travel back in time and prevent their own birth. Throughout the book, Hawking also asks big questions about the universe. Does the universe have a purpose? Is there a final theory that explains everything? He talks about the search for a theory of everything, a single set of rules that could explain all the forces in nature. Scientists have found rules for gravity, electricity, and nuclear forces, but they have not yet found a way to combine them into one complete theory. Hawking hoped that one day we would find this final answer. One of the most promising ideas is called string theory, which suggests that the smallest building blocks of the universe are tiny vibrating strings. However, this theory is still being tested and is not yet proven. Hawking also explains how quantum mechanics, the study of tiny particles, plays a role in our understanding of the universe. The world of very small particles, like electrons and quarks, follows different rules than the world of big objects, like planets and stars. In quantum mechanics, particles can be in multiple places at the same time until they are observed. This strange behavior makes it difficult to predict exactly what will happen in the universe. Hawking explores how these ideas connect with black holes, gravity, and the origins of the universe. He describes how tiny particles might behave in ways that seem impossible, but they are still real. This is why scientists need to use both relativity and quantum mechanics to fully understand the universe. The book ends with thoughts about the future of science. Hawking believes that science should be available to everyone, not just experts. He encourages people to keep asking questions and learning about the universe. He also wonders if we will ever fully understand everything about space, time, and reality. He suggests that there may always be new discoveries and mysteries waiting for us. Science is always growing, and what we know today might change in the future as we learn more. A brief history of time helps people see the universe in a new way. It explains science in a way that many people can understand, even if they are not scientists. Many people around the world have read it, and it continues to be one of the most famous books about science. Hawking's work has helped bring difficult ideas to a wider audience, making us all more curious about the world around us. His ideas continue to influence scientists today, and his book remains a guide for anyone interested in understanding the universe.